All right, cool. So the next team's name is Playground AR, which I assume has something to do with AR.
Yes, yeah. So if you've ever been bored, which I think we all have at some point in our lives, this now gives you a beautiful opportunity to submerge yourself into an augmented reality experience. I'm excited to hear more about it, so let's see how they did it.
All right, let's do it.
Hello everyone, I am John Vitalis, and my teammates are Robert Schneck, Harsh Patel, and Ethan King, and we are the creators of Playground AR. Playground AR is an augmented reality puzzle game where players can interact with different 3D objects to collect coins. Grab all the coins, and you win the game. From the main menu, a new player can click on Tutorial to get a brief overview of how the game works. From there, they will be taught on how to calibrate their phones to the playground. Players will be given audio and visual cues to let them know that calibration has been successful. If not, they can recalibrate by pressing the recalibrate button on the bottom menu screen. From there, players can walk around the room and collect coins. Once that's done, they will be prompted to try out the actual game mode or to step into the portal for a free play. Now Rob will walk us through the actual game mode.
Thank you, John. Aside from the tutorial, users can either press play or click to load a map that's pre-generated that comes with our app. But it's not just simply coins. You actually have to interact with the world around you, like that heart. And all these objectives won't be seen until you get close enough, like this smiley. All of a sudden, the smiley appears there. Our objectives can either be you click them and they spawn into a coin, or perhaps you have to click them and it stores into your inventory for later, like this key. Perhaps we need to find a lock. And guess what? We just found a lock. So maybe we can actually click on our inventory, deploy the key, so that the key comes back into the AR world, and then you can click and drag the key so that you can collide into that lock, and then the lock, boom, turns into a coin, and we clear that objective. And now here's Harsh to tell you about the technologies we used and the struggles we faced.
Thank you, Rob. So our app is built off React Native and ViroReact, which is a development platform used to create AR and VR applications. So we chose to use React Native because it has cross-platform compatibility as well as native rendering for better performance. Whereas we chose to use ViroReact because of its quick development and quick testing, since Viro provides an app which makes testing as simple as refreshing a page. So since React Native doesn't work within ViroReact, we actually had to stack them on top of each other. However, connecting these two technologies and making them communicate with each other created a whole new set of problems. So to solve this, we used Redux, which acted as a middleman to make the two technologies talk to each other. And this created a seamless connection between the AR world and the Android or iOS environment. So for example, one of our key features is our inventory, which allows the users to walk around the AR world and collect objects and store them into inventory for later use in the game. So this is all handled by the Redux store and managed by that. So Redux was an absolute key in making this game work as cleanly and as efficiently as possible. Now, here's Ethan talking more about some of the other struggles that we faced.
Thank you, Harsh. I'm going to talk about the challenges in implementing proximity blinding. So we tethered our board to an anchor, which was our logo, so that we could predictably place 3D objects in the AR world with that anchor as a reference. To achieve this, the anchor assumes position coordinate 0, 0, 0. However, Viro also labels the position from which the app is started as the origin, 0, 0, 0. In effect, this creates two origins on the same grid, and our challenge was establishing a channel of communication between them. To solve this problem, we use vector geometry. By translating the relative position vector of the 3D object by the absolute position vector of the anchor, we were able to remove the noise generated by the anchor and calculate the distances appropriately. This way, if an object is too far away from a user, they won't be able to see it. In the future, we would like to have the option for a game master to walk around the room and set the location for the object at his or her discretion. Thank you for your time. We are Playground AR, where the world is your playground.
I want to play right now. I know I said that about the last one, but I want to play this also.
Yeah, so many good games. I think this one was really interesting because I loved definitely their approach, as well as like these little caveats of you know, having it appear only when you're close enough and stuff like that, which definitely probably took a lot of like calculating and figuring out how far you are from these different objects that
Yeah,
you're looking for.
definitely. They definitely leverage a lot of math in that one, and like I've seen a lot of projects. We've seen a lot of projects with using Vero and whatnot, and sometimes it's hard to be able to calculate collision and all that stuff and be able to appear at specific points. So the fact that they were able to do that, like, you know, in such a short period of time too, was definitely very, very impressive.